So hello, this is AP Chem Unit 8.1 to 8.4 cheat sheet. So I'm going to run through the flow of every concept and I'm going to try to connect it so you can really understand the gist of what this unit is going to talk about. So firstly, 8.1, you get introduced to the concept of pH and pOH. What happens is, say we have water. Water is expressed as H2O, right? And if we have water, most of the cases, water remains as H2O, but in very few cases, it separates into a H plus and OH minus ion. And we're going to focus on this. And sometimes two H2O molecules separate into H3O plus and OH minus. And depending on the ratio between how much of H plus and how much of OH minus is within the solution that we have, the characteristic of this solution changes, and we divide it into two categories. If there is more of the H, it's called acidic, and if there is more of the base, it's called basic. So we focus on the H plus or the H3O plus ion for it to be acidic, and for it to be basic, we focus on the OH minus ion. And how we express this is because, as I've mentioned, most of the time the water molecules in the solution just stay as H2O, and in very few cases it separates into H plus and OH minus. So because these cases are very little, the concentration of these ions are also going to be very little. So these little values are expressed in more bigger numbers by adding a negative log to it. So if we have a scale, 7 is going to be where the pH is called to be neutral. And if it is lower than 7, it is going to be called acidic. And if it's bigger than 7, it's going to be called basic. So the more acidic something becomes, the more H plus ion there's going to be. And the more basic something becomes, the more OH minus ion there is going to be. And this is the concept of pH and pOH. And now that you have that, we can move on to the second topic. So 8.2 and 8.3 together talk about the strengths of the acid and bases. So we have a strong acid, we have a strong base, and we have a weak acid, and we have a weak base. So there are 4 categories in total. Let's start by looking at the strong acid. So a strong acid is basically, because it's an acid, it's going to have a H plus molecule in it and another conjugate base attached to it. And it's going to exist like this in the solutions. But by strong, it means that it is very good at breaking free from these and making the entire solution more strongly acidic. Because if in this kind of state, we can't really say that this is an acid, but once this H plus ion breaks free from its conjugate base, this is what makes the solution acidic, a single H plus ion. And for strong bases, vice versa, it's basically saying that there's an OH minus ion with a conjugate acid, and it's going to look like this, but it's going to be very good at breaking free from these bonds and making the solution more basic by these singly floating OH minus ions. And strong acids and strong bases, you do have to memorize what they are. So for strong acids, these are all the strong acids. You only have to memorize these 6. And for strong bases, you only have to memorize these. But for strong bases, you don't have to really memorize them, because if you see here, there's lithium, sodium, potassium, rubidium, and all these kinds of things, and they are all the group 1 of the periodic table, if you see here. And also for these ones, they are all in group 2. Just remember that there are going to be 2 OH minus ions for these strong bases. And for strong acids, unfortunately, you do have to memorize them: Br, I, Cl, NO3, SO4, and ClO4. So, yeah. And now onto the weak acids and weak bases. So, in the case of strong acids and bases, they dissociate 100%. So, say H plus and A. If you say that this is a strong molecule, and if there are multiple of these molecules inside the solution, every single one of them is going to dissociate into a H plus ion and an A ion. But in the cases of weak acids and weak bases, because they are weak, they're not very good at separating from each other. So some are going to separate and some aren't going to separate. And that ratio of the ones that have separated and that have not separated, we express with a K value. So say that we have an equation like this, then we have the products on this side and the reactants on this side. We're not going to look at water because this is a liquid. Everything else is an aqueous solution, so we are only going to regard these. We put the products on the numerator and the reactant on the denominator, and this is how you get your K value. And because this is an equation of an acid dissociating, this is going to be called Ka for acid, and this one is based on this equation of a base forming, so this is going to be called Kb for base. So to recap what we've seen so far, firstly, we learned about pH and POH, the concept of pH and POH, and then we moved on to the types of acids and bases, how it can be a strong acid, strong base, or a weak acid or a weak base, these 4 types. And now what we're going to do is we're going to start making combinations with these 4 types of weak acid, weak base, and strong base. So all you have to do to be able to solve the problems is to have this chart in mind. So first of all, if we say that a weak acid and weak base react, we are just going to write the equation of the reaction and use the ice table in order to get what the question is asking us for. The question usually asks for like the pH of the final solution, or what is the excess or the limiting reactant, and that can all be done with the ice table. And say strong acids and strong bases are reacting in this table, you're also going to just write the equation and solve it with the ice table. Now, where it gets a little bit complicated is when a weak base and a strong acid reacts, because there are 3 results for what could happen. So firstly, if the weak base is the one that's left, which means that the strong acid was the limiting reactant, a buffer solution is going to be formed. Whenever a weak something is left, a buffer solution is formed. And when a buffer solution is formed, you're going to use the Henderson-Hasselbalch equation that I'm going to be explaining right here in just a moment. And when there's a strong acid left, you're just going to figure out the concentration of the H plus ions and find your pH based on that. And equimolar, when the strong acid and weak base have all reacted and there's nothing left, you write the equation and you use the ice table. In the case when a weak acid, and for the case in which a weak acid and a strong base reacts, we're going to use, there are also going to be 3 categories. So first of all, when the weak acid is left, you're going to use the Henderson-Hasselbalch equation because a weak acid is left, this is also going to be a buffer solution. And when a strong base is left, you're going to be calculating the concentration of the OH minus ions and getting your POH from that, which you can get your pH from, because pH plus POH equals 14. And when it's equimolar, you use the ice table by writing out the equation like this. So now onto the Henderson-Hasselbalch equation. This equation you do have to memorize. A lot of the teachers recommend you do memorize it, and it's very important because it saves a lot of time. And in your logic or explanation for your FRQs, you could say according to the Henderson-Hasselbalch equation, blah 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 blah. So it's very helpful, so make sure you memorize this. But if you find, I'll explain how this equation is made so you can understand it a little bit better. So say you have this kind of equation, and from this you've made Ka, which we've looked at over here. And from this Ka value, you are going to add a negative log to each side. And then negative log Ka is equal to pKa. And negative log H3O plus, like this, is going to equal pH. And then whatever, this much left, you're just going to write it negative log, negative, and like this. So this turned into this. From here, if we just take this to the other side, we are going to get pKa plus log A minus over HA equals pH. And this is how you get the equation. So a general recap. First of all, we looked at the pH and the pOH. Then we looked at the 4 types, which were strong acid, strong base, weak acid, then weak base. And then we looked at the combinations of these weak acid, weak base, and strong base, where if you just know this chart, you could use it for whatever question that comes up in your AP exam. And then I explained the Henderson-Hasselbalch equation, where you have to use for buffer solutions here and here. And how you get this is by just kind of playing with the Ka equation. And that is it. That is it for unit 8.1 and 8.4.